Aerospace engineering usually advances in small, incremental steps, with each breakthrough building on decades of research, testing, and refinement. Progress is often measured in subtle improvements, lighter materials, more efficient engines, or smarter guidance systems. But every so often, a new design emerges that signals a dramatic leap forward, capturing the imagination of engineers and the public alike. In November 2024, at the Zhuhai Air Show, China unveiled the latest Long March 9, a super heavy-lift rocket that immediately drew comparisons to SpaceX's Starship, both in scale and ambition. The resemblance was striking, sparking lively debate about inspiration, imitation, and the future direction of global space exploration. Experts and enthusiasts alike wondered, is this the dawn of a new era or a race to catch up? Unlike earlier expendable designs, this Long March 9 is a two-stage, fully reusable system, aligning China's ambitions with the reusable rocketry pioneered by SpaceX. This marks a fundamental shift in philosophy, one that prioritizes sustainability and cost-effectiveness. The shift is significant. China's space goals, from building lunar bases to launching Mars missions, demand a vehicle of this scale and capability. The Long March 9 is designed to support not just single missions, but a sustained human and robotic presence beyond Earth. The rocket's advanced specs and reusability are tailored for a future where frequent large-scale launches are the norm, not the exception. It's a blueprint for a new era of space infrastructure. This move shows Chinese planners see rapid reusability as essential, echoing conclusions SpaceX reached years ago. The lessons learned from others are now being adapted and advanced in China's own way. The unveiling marks a new chapter in the 21st century space race, where national prestige, economic opportunity, and technological strategy all collide on a global stage. The competition is no longer just about reaching space, but about shaping its future. The Long March 9, with its Starship-like design, signals China's intent to be a leading force in this new era, not just a participant, but a true contender for leadership in space. Its development, targeting a first flight in 2033, will be closely watched as a key part of humanity's expansion beyond Earth. The world now waits to see if this new giant will deliver on its promise and help define the next chapter of space exploration. Side by side, Starship and Long March 9 share more than just looks. Their specs are nearly identical. Starship stands 122 meters tall, designed to deliver 150 tons to low Earth orbit, powered by 33 Raptor engines. The new Long March 9 is almost as tall, with the same payload target and a similar cluster of 30 Methalox engines. Both rockets are two-stage, fully reusable, with boosters that land propulsively and upper stages featuring large control surfaces for atmospheric re-entry. China's adoption of these features suggests a direct response to SpaceX's proven design. The multi-engine approach offers redundancy and precise control, critical for reusability. By 2024, SpaceX had already flown 5 full-scale Starship tests, providing a wealth of public data for others to study. For China, building on a validated design accelerates development and reduces risk. Both rockets use liquid oxygen and methane, Methalox, a choice that shapes their entire design. Methane offers better performance than kerosene and is easier to handle than hydrogen, making it ideal for reusable engines. SpaceX's Raptor engines burn cleaner, allowing for rapid turnaround and minimal refurbishment. Methane's chemistry also enables in-situ resource utilization on Mars, a key part of SpaceX's long-term vision. China's new YF-215 engines for Long March 9 reflect the same logic, optimized for reusability and future Mars missions. The adoption of Methalox by both nations signals a new industry standard. SpaceX's public success with Raptor de-risked the technology for others. China's Methalox pivot is a logical step, leveraging proven concepts to focus on scaling and implementation. The convergence on methane shows a shared vision for making humanity multiplanetary. After the Long March 9 reveal, attention turned to its engines. Had China copied SpaceX's Raptor? Despite speculation, there's no evidence China has duplicated the Raptor 3. SpaceX's engine development remains a story of relentless public iteration. Replicating such a complex engine without proprietary data is far harder than copying a rocket's shape. Building a full-flow staged combustion Methalox engine is one of rocketry's toughest challenges. China's YF-215 is likely an independent design aiming for similar performance, not a direct clone. Rocket engines are products of deep institutional knowledge and iterative testing, something SpaceX has mastered. For now, claims of copying remain unsubstantiated, fueled more by visual similarity than technical evidence. The Starship Long March 9 debate is just the latest chapter in a long and complex history of technological convergence between the United States and China. This story stretches back decades, shaped by shifting alliances, global ambitions, and the relentless pursuit of innovation. In the early days, the West actively encouraged technology transfer to China, hoping to foster cooperation and mutual growth. International conferences and joint projects were common, as both sides saw benefits in sharing expertise. But as China's capabilities grew and strategic competition intensified, attitudes shifted dramatically. Laws like ITAR and the Wolf Amendment now strictly block NASA-China cooperation, aiming to prevent sensitive technology from crossing borders. These legal barriers reflect deep concerns about national security and technological advantage. Yet, in today's internet age, much technical knowledge is widely accessible. SpaceX's dramatic test flights, Musk's frequent social media updates, and live streams of rocket launches are open to anyone with an internet connection, making secrecy harder than ever. Chinese engineers can study public data, analyze test videos, and learn from open discussions online. This easy access blurs the line between drawing inspiration and outright imitation, making it difficult to define where influence ends and originality begins. The evidence suggests that China is following a successful and openly available model, rather than engaging in outright theft. Their engineers are leveraging what's public, adapting and improving upon it in their own way. The reusable, Methalox-powered super heavy-lift rocket is now a public concept, championed and popularized by SpaceX. This idea has become a global benchmark for next-generation launch vehicles. China's path is a logical response to proven success, a common pattern in the history of technology where nations build on each other's breakthroughs to push the boundaries of what's possible. Ultimately, it's inspiration, not espionage, that is driving this new era of technological convergence and global progress. The development timelines reveal the relationship. SpaceX's Starship is the innovator, China's Long March 9 the fast follower. SpaceX's journey began over a decade ago, with public prototypes, spectacular failures, and hard-won successes. By 2024, Starship had completed 5 integrated test flights, proving the system's viability. This real-world data became a blueprint for others. China's pivot to a Starship-like Long March 9 in 2024 was a strategic shortcut, skipping years of trial and error. Their 2033 first flight target is ambitious but more feasible thanks to a validated design. The distinction is clear. SpaceX bore the risks of innovation. China leverages that to iterate quickly. This is a common pattern in technology. Innovators blaze the trail, fast followers accelerate progress. The timeline shows Starship's lead. The question is how quickly China can close the gap. The race is now about execution and scale. The engine is the heart of any rocket, and here the US and China are locked in a high-stakes contest. SpaceX's McGregor facility is a hub of rapid, hardware-rich testing. Engines are pushed to failure, dissected, and improved. This relentless cycle has made Raptor a world-class engine, with record burn times and rapid relight capability. China, though more secretive, is developing its own Methalox engines, facing the same technical hurdles. Mastery isn't just about thrust, it's about manufacturing, refurbishment, and reusability. SpaceX's head start is clear, but China's focused, state-backed approach is formidable. The outcome of this engine race will shape who leads in deep space access. The world is watching Texas and China's test sites for the next breakthrough. The Long March 9 Starship-like design transforms the space race into a direct contest of similar architectures. For the first time, two nations are developing rockets with nearly identical capabilities, setting the stage for a technological rivalry that echoes the Cold War, but with new stakes and ambitions. For SpaceX and NASA, the pressure is on to make Starship reliable and operational, especially with Artemis III on the horizon. Every test flight, every milestone, is now watched not just by engineers, but by policymakers and the public, aware that the outcome could shape global leadership in space for decades. China, with Long March 9, now has a credible path to lunar and Mars missions, focusing on execution and scale. Their rapid progress and state-backed resources mean they could close the gap with the US faster than many expect, making the race even more unpredictable. Two superpowers with super heavy-lift rockets means a new era of competition and risk. The stakes are higher, and the margin for error is smaller, as each side pushes the boundaries of what's possible in space. Competition can drive innovation, accelerate timelines, and inspire a new generation. The excitement of this new space race could spark interest in science and engineering worldwide, fueling discoveries that benefit all of humanity. But it also risks creating rival blocs, resource disputes, and missed opportunities for collaboration. The Moon and Mars could become arenas for geopolitical tension, rather than shared exploration. The lack of communication, worsened by policy barriers, increases the chance of misunderstanding. Without open dialogue, even small incidents could escalate, threatening peaceful progress. The best outcome is a balance, healthy competition that drives progress, and frameworks for peaceful shared exploration. International agreements and trust building will be essential to avoid conflict and maximize the benefits of space for everyone. The stakes are scientific, economic, and geopolitical. Whoever leads in space could shape the rules, set the agenda, and unlock new resources for their nation. The world's future in space depends on how this rivalry is managed. Whether it leads to conflict or cooperation will define not just the next decade, but the future of humanity beyond Earth. China's Long March 9 mirroring Starship marks a turning point in spaceflight. Full reusability is now the global standard for deep space ambitions. Starship's public development served as a template for China's design, but the real story is about the power of revolutionary ideas. The engine race is about mastering systems, not just copying parts. SpaceX's lead is built on culture and iteration. By the 2030s, both nations could send people and cargo to the Moon and Mars, unlocking new opportunities and new risks. The next era of exploration will be shaped by both competition and the need for cooperation. National pride will fuel the race, but the scale of the challenge demands collaboration. The true test will be harnessing rivalry to drive progress, while building the diplomatic frameworks for a peaceful, shared future in space.